Physics 2054, Fall 2011, questions 4, 5, and 6. Questions 4, 5, and 6 are all very similar to each other, so I am going to solve a general case and then plug numbers into it to get the right answer. So the question says you have an electron, you've got some sort of an electric field, and it asks what the acceleration is. Okay, so this is a perfect problem. If you're stuck, look at dimensional analysis. The electric field is equal to, let's call it x newtons per coulomb. Now what you want is a force. Force is measured in newtons. So in order to get from electric field to force, you need to multiply by some coulomb unit, which it just so happens it provides, being the charge of the electron. So F equals the charge of the electron. Let's 1.6 times 10 to the minus 19 coulombs times x newtons per coulomb. Now another equation you should know is force equals mass times acceleration. So all of this is equal to ma. If you look at the useful constants at the front of your test, it will tell you what the electron mass is. 9.11 times 10 to the minus 31 kilograms. Okay. So acceleration is equal to 1.6 times 10 to the minus 19 over 9.11 times 10 to the minus 31. Let's see, that's coulombs per kilogram times x newtons per coulomb. Now, if you plug that into your calculator, you'll actually find that that is equal to 1.8 times 10 to the, what is that? That is 1.8 times 10 to the 11th. Times x. And then the units would be meters per second squared. Great. Now let's plug in values for x. Problem 4. X equals 100. Therefore, the acceleration equals 1.8 times 10 to the 11th times 10 to the second meters per second squared, which is equal to 1.8 times 10 to the 13th meters per second squared. Great. For problem 5, x is equal to 33. And once again, you plug it in. So it leads to 1.8 times 10 to the 11th times 0.33 times 10 to the second. Now the reason I'm changing that, the reason I am changing that from 33 to 0.33 times 10 to the second is because it asks for the units in 10 to the 13th meters per second squared. And so I'm just doing the fastest way to get to 10 to the 13th. And if you plug all of that into your calculator, you should get 0.6 times 10 to the 13th meters per second squared. And number 6, x is equal to 50. Well, right off the bat, you can look at this, and you say, okay, well, this x is 1/2 of that x. And x is raised to the first power here. So Shouldn't this be exactly 1/2 of that? And you'd be right. The answer is 0.9 meters per second squared. Or, right, times 10 to the 13th. And that is how you solve an electron accelerating problem.